Hello, everybody. I record this lecture today. We have only 3 students right now in my class. So there's a chance that this class get canceled. However, let's just go on with as if this class will go on. Let's start with our syllabus. This class will run from 11:10 to 2 o'clock, Monday to Friday. Sorry, I write something wrong here. This should be Monday to Friday. And my name is Thomas Arjuno. I will do my office hour on Friday, 10:10 to 11:10, unless there's a test on that week. The dates for the test will be provided below. But let me just go on with this first. My email listed here. I have 2 email addresses. When you send me an email, send it to both email addresses. Okay. The website is harjuno.com/harjuno. I will show that to you later on. That's a very big portion of my introduction here. The textbook we will use is Precalculus Functions as Graph by Sokowski. I think in my announcement, hold on, do I share it? Okay, this is my website. This is the course syllabus. Okay, and then yes, this is both of my email addresses. Okay, when you send me an email, send it to both because there's a chance, just in case, you know, like one of the email is not working, then I still get it from the other email. My office hour will be from Friday on Friday, 10:10 to 11:10, unless if we have a test on that week. So let's say on that week we have a test on Wednesday. So I will run my office hour prior to that test at from 10:10 instead of on Friday. Okay, so this Friday I will have my office hour from 10:10 to 11:10 because we don't have test this week. Okay, but our first test will be next week on the 8th. So on Wednesday next week, I would run my office hour from 10:10 to 11 o'clock. Okay. Now, the website I will go over with you later on. That's a very big portion of this course. Okay. The textbook, I believe I mentioned that in my announcement about textbook. Let's see. For textbook, we will use this textbook. Yeah, we'll use this textbook. Okay, this is what it looks like. Yeah, this is what it looks like. Now, of course, if you don't have this book, right now, and I do suggest you to have it as soon as possible, I strongly suggest you to get the ebook so that you can get it right away. Okay, now I hope the ebook is not too expensive though. Let's see, where's the ebook? Yeah, the ebook is here. The ebook is 33.20. Yeah, or of course, if you can get the used book super cheap, if you can get it super cheap, go for it. But don't wait for too long. Okay. If you have other, oh no, this is other book though. This is not the same. I'm sorry. This is not the same. This is not the same. Yeah, this is the ebook, the one. As long as you see this cover, you're fine. Okay, as long as you see this cover, you're fine. And then let's go back to beside textbook, calculator. You can use any calculator as long as it doesn't have the graphing capabilities. It has to be scientific because you need to have the one with trigonometric and logarithmic function. Now, the one I suggest you to have is either TI-30XX Multiview or TI-36X Pro. Okay, now the one commonly used by other instructors is TI-30. Actually, any TI-30, but if you're any TI-30, but among all TI-30, the one I suggest is this one. or otherwise use TI-36X Pro. Okay, this is what it looks like for TI-30. Let me make sure that you see that. Okay, this is what it looks like for TI-30. Okay, well, you may have different color. That's fine. Okay, and of course, I don't expect you to buy this from Amazon because it takes some time for that to arrive. Go to Office Depot or Staples, you will get them there. And they are actually quite cheap. I'm pretty sure it's less than $30. Yeah, I'm pretty sure it's less than $30. Okay. What else? And then the other calculator, TI-36X Pro. TI-36X Pro looks like this. Now, the good thing about, now the thing is, I'm not sure if your Precalculus, your calculus teacher will allow you to use this calculator in your calculus class. Should be okay. It should be okay. But the good thing about this calculator is it can handle some basic statistic work. That's why if you are taking a Precalculus class, I strongly suggest you to take statistic class also to make your transcript look a lot better. And I mean, that's useful for you. Okay, and for that to happen, you may need TI-84, and TI-36X Pro is actually one basic calculator for statistics. Okay, well, anyway, either this one or this one. Okay, either this one or this one. These two calculators are the ones I suggest. And this is the textbook, right? Okay, and what else? Yeah, let me go back to our syllabus. Prerequisite, you should have taken Math 20, which is intermediate algebra, or in high school that will be algebra 2, and Math 32, elementary geometry or simply geometry. In high school, that's geometry. Okay, now what is this course? This course actually to prepare you for calculus. You can see that this class is actually combination of college algebra and trigonometry put together. Okay, course objectives, basically what we plan to cover in this class. Okay, to summarize all these points here, I basically say I'm trying to prepare you to be successful in your calculus class. Okay, so yes, you need to have some good foundation in your algebra. Okay, we need to strengthen your algebra and put things together. Okay, grading, homework, 10%. When I give you homework, I will give you at least 24 hours to turn it in. Now, you already have one homework that I would like you to do though. This one is extra credit. Actually, you go to assignment. Okay, then you will see quiz 0. I basically want you to, let me show you the preview. Yeah, basically, I would like some information from you. Okay, but I would like you to print this out and then write it, and then you scan it. Okay, you print it out, you write it on that paper, and then you scan it. Thomas, what happens if I don't have printer? Then just write it on a piece of paper. Okay, even though I still suggest you to have a printer, or maybe you borrow, you go to your siblings' place to print out. Okay, but imagine I'm training you to take my test next week. Okay, yeah, I'm imagine if I give you a test and then you cannot type it, you have a lot to write. Of course, it will be faster if you write it, right? Then imagine if you print it out, work it out, right? Okay, now if you don't have printer, then just write it down. You don't need to write the question anymore. Okay, of course, unless it's not clear which question you are referring to, then you write the question a little bit down. Okay, and then what happens if you don't have scanner? Now, the good thing is I assume, I think that's this is a pretty good assumption that most of you must have smartphone, right? So you can use some app on your phone. If you have Android, my former students suggest to use Cam Scanner on Android. I think if you have iPhone, there's an app for that. I was told that you use Note, and you can take the picture, convert that to PDF file. Okay. The key part is like I need you to scan it into a PDF file. If you don't have scanner, you take the picture and then you convert that to PDF file, and this Cam Scanner can do it. Okay. Now, what happens if you have iPad or a notebook or anything that you can electronically write on the file directly without printing it out? Now, if you feel comfortable to do so, go ahead. Okay, just so you don't need to print it out. If you don't want to print it out, but you can just write it electronically to your iPad, for example, then go for it. Okay, go for it. Okay, as long as you can save it as PDF and then you upload it back to me. Okay, now once you upload your work, I will provide comment. At least I will provide you the grades. Okay, and for this quiz 0 here, in case I would like you to do it, and I will let you know also. Okay, but this quiz 0, consider that an extra credit, 5 points extra credit, 5 points extra credit for which I want you to practice how to turn in your work to me. Okay, I give you until July the 5th to turn it in. Almost midnight, July the 5th. So you can celebrate July the 4th, right? And still have the next day to turn it in. Okay, that's for the quiz 0. And the way you turn in your other quizzes will be pretty much the same. And of course, your test also. Now, if you see the assignment here again, you also see my test 1. I don't post the file yet. But I want you to see what you will do with your test 1 later on. Okay, I hope you realize that it will basically mimic what you did with your quiz, except that when you take my test, you need to be synchronously online together with me. Okay, so I will post the test at 11 o'clock. Okay, you stop working at 1:15. Okay, you set your alarm at 1:40. This is for next week, by the way, Wednesday when you for test 1. That's my test and final are the only time I require you to be synchronously online together with me. Okay, now, so basically you print it out, you work it out, and then you scan it, make sure that you finish long before the deadline, 2 o'clock. Okay, and then you turn them into Canvas under assignment test 1, not to my email. Then make sure you have 10 to 15 minutes to upload it. Okay, yeah. Now I strongly suggest you to email me the files before you upload it to Canvas, just in case your upload does not work. Okay, now if you don't have printer, what happened? That will be the same to your quiz later on. What happened if you don't have scanner? That's the same. What happened if you upload with your phone? Then please get good signal. Okay, which means you may need to get to open space, either near or outside your window or door. Okay, now if you have a Surface, iPad, or basically you can electronically write it to the file directly without printing it out, and you can do so comfortably, go for it. Okay, as long as you save as PDF and upload it to Canvas. Now, for your test, you need to prepare your own scratch paper, but you don't need to turn it in. Okay, however, everything you want me to see should be presented in the work you turn in. Now, you need to present your work, basically your quiz, your test, especially neatly, clearly, systematically, and understandably. That's so that you know the direction for your test 1, and your test 2, 3, and 4 will be very similar to this. Okay. Now let's go back to syllabus. Let's go back to syllabus. We're done with the test textbook. We're done with the tests. Okay. The homework is basically your quizzes. Your test 4, however, no makeup test. Why? Because your test 4 is very, very close to the final. I'm sorry, this is not the department final. I need to delete that. Change that. That's not the department final. The final will be from me, not from the final, not from the department. because the final is only 2 days after your test 4, I will not give you a makeup test for test 4. And the reason is because if I let you do makeup for test 4, then you will have less time for your final, and that's bad. Okay, that's bad. I do allow, as you will see later on, I allow 1 makeup test for your test 1 or test 2 or test 3 or final. Okay, only 1 though, okay, but not test 4. Okay, now what happens if you miss test 4? Then depends on how many times you have missed the class. Okay, depends on if you have excessive absences and you have no chance to pass the class, I will just let you go. I will drop you already. Okay, but suppose you always attend the class, right? I will show you how I will take your attendance later on in case of lectures. For tests, you need to be synchronous, synchronously online. Okay, but for test 4, what happens if you always attend the class, satisfy my attendance, and let's say you miss only 1 class so far, then I don't give you makeup test, but I will consider your final for your test 4 grade. In other words, if you miss test 4, okay, if you miss test 4, then I will just let you take the final. Whatever you get in your final, let's say you get 90 points in your final, that's the grade I will copy paste in your test 4. Okay, so if you get your final, you get 90s, then your final will get 90, your test 4 will also be 90. That's if you miss test 4. Now, usually that's not the case though. Usually that's not the case. If you take test 4, usually test 4 grade is higher than the final. Okay, but try your best not to miss anything. The grading cutoff, my A is 90, my B is supposed to be 80, I make it 79. My C is supposed to be 70, I make it 68. So I don't curve anymore. Okay, I changed the grading cutoff to be a bit more generous, and the total percentage is also more than 100%, right? But I don't do any curving anymore in the end. Okay. Last days to add will be July the 3rd, which is this Friday, huh? Yeah, it will be this Friday. And last day to drop without fee will be on Monday, without W also on Monday. Last day to drop with W will be July 29. I guess we don't worry about that, right? Okay. Now, for those people who are not added to the class yet, or just want to add to this class, then yeah, please observe this last day to add. Okay. Now, the notes. Having a textbook is a must. No one without textbook ever passed my class. I've been teaching for quite a long time. At least 13 years full-time. And no one without textbook ever passed my class. I need you to get the book, okay? It's not that the book is... the book is a source for you to study. So without textbook, you don't have a source to study, okay? But Thomas, it means you are not 100% reliable. Well, I need exercise set, and you will get, I would recommend you to do problems to practice from problems in the book. Okay, so if you don't have the textbook, then yes, you don't have any avenue to study. Okay. Second, this is what I was said earlier about how I will take your attendance. I will not require you to attend my lecture synchronously. Okay, however, I need you to reply here on each day on discussion board for that day. So for today, I need you to go to, you will see, I need you to go to discussion. Okay, and then on this discussion here, you will say here. Ah, I like it. I get 2 of you already done that. Nice. Yeah. Okay. Now then, let me go back to the syllabus. Yeah. So just reply here for this, and then I consider you present already. Okay. Now I usually leave this discussion board open for 2 days. For 2 days. So it means on July the 1st, I will close it already. I basically need you to keep on updating me that you are still in this class. Okay. Go back to the syllabus. I made the right place, right? Yeah. Let me go back to the syllabus. What else? No makeup test or final exception only given in case of emergency. If you can show me demonstration of proof of emergency or unavoidable legitimate documented absence. Only one makeup test or final will be allowed. I don't drop any tests. Only one makeup test for test 1, test 2, test 3, or final, but not for test 4. Okay, not for test 4. No late homework will be accepted. You will have at least 24 hours to turn in your homework. In my case, that's also your quiz. Okay, now during tests and final, you will be required to be online with you, your test, your stationery on your desk, visible and audible at all times. Okay, so you have a couple of days to figure out how to make it happen. Basically, you need to have your webcam and microphone. Or if you have cell phones, download that Canvas. Okay, download Canvas, and then you can go Zoom from there. Then it will use the camera and the microphone from your phone. Okay. I don't want to be too strict with this. That it has to be feasible. You know. At all time, audible at all time. Just give me some barely enough so that I can confirm, hey, you are the one taking the test and you are not collaborating with other people. Okay? Yeah. What else? No, I don't curve your grades. Studying hard sometimes results in good grade, but never expecting a good grade if you don't. Keep in mind that our purpose here is to especially to prepare you for calculus class. Okay? So what I don't want to happen is I just barely pass, simply pass you. Of course, you will be happy and I don't care, but then you will struggle so much in your calculus class. No, that's not your purpose to be here. Your purpose is to be prepared for your calculus class. Okay, so you may have some hard time here and that's normal. Okay, especially in the summer, right? Yes, that's normal, but of course you need to work hard. Okay, make it in a way that at the end of this class, when you pass this class, that's something you really earn, and not simply because of my mercy or simply because you have a teacher who don't care. Okay, I care. That's why I prepare you for that. Okay, if you see my website later on, you will see that I usually teach Calculus 2 and Calculus 3 classes. And of course, I don't want students who are not prepared in my Calculus 2, Calculus 3 classes. Now, for that to happen, then I want to prepare you for other teachers so that those teachers can prepare good students also for me in future. Okay, and it's really about you though. It's really about you. Okay, what else? Testing policy, closed book, closed note, scientific calculator required. So I assume you will use TI-30, the one I showed earlier, or TI-36, the one I showed you earlier. Either one is good. Okay, and closed neighborhood. Basically, I don't want you to collaborate with anybody. Not with other students, not with tutors, not with anybody else on chat. Trust me, there's no way to do that. Okay, and I can find out if you do that. Okay, yeah. About closed book, closed note, that's something I will go test by test. Like for your test 1, I don't think you need closed. I don't think you need open book, open notes. But I think in your test 3, you may need open book, open note to be a bit helpful. Okay, but we talk about that when we are very close to each particular test. Warning for repeating students, basically just don't slack off, don't skip classes, okay? Yeah, if possible, update yourself every day, especially because our class is nearly 3 hours on daily basis. Effectively 2.5 hours if I include the break. Now, 2.5 hours that you miss, if you wait until the next day, you miss another 2.5 hours, that will be too much, okay? That will be too much for you to catch up. Yeah, every 2.5 hours, I expect you to spend around 3 to 5 hours study before the next day. Okay, so Thomas, if I'm working full time, what should I do? Sleep less. That's one thing you can do. But yeah, of course, there are so many things you need to do though. So please manage yourself, manage your time. Okay, but if you ask me how much time I expect my student to study at home, like study and do suggestive homework and do the quizzes for you to turn in. approximately 5 hours. Okay. Now, I say this not because I never feel what it, I never be a student. No, I was a student. That's how I get this job, right? Okay. In fact, I studied a lot longer to get this job. So I know what it feels to be a student, and trust me, you need it. Okay, you need it. Of course, try to manage yourself, manage your time, so that you have more time to study and balance. Of course, balance your life. Okay, if you have a big family, you have children, a full-time job. Of course, that's too much work in your plate. But if you really willing to take that risk, it means you need to sacrifice a bit from your sleep time. Okay, not that I don't understand that. I was there before, but I still make it. Okay, yeah, but it's not an easy life. Trust me, it's not an easy life. Especially this 5 units course is equivalent to it should be done in 6 weeks, right? So it will be so fast, and for that to happen, we don't expect this to be as easy as doing it in 15 or 18 weeks. Okay. During test or final, maybe record it. I need to formally say this on my syllabus to be in line with the California law. California law says that if I record anybody, I need to at least tell that person. Okay, I don't need that person permission actually. Okay. I don't need, but no, I'm not really into this though. It's just formality. Okay, basically, I want you to keep your integrity. Okay, keep your academic honesty. Be honest. Okay, and what else? I recommend you to take at least. This is for spring class. My bad. Let me update that further. Should be at least 3 hours on daily basis. At least 3 hours to study every day during this summer. Maybe more. Yeah, I would say 5 hours. After the first test, you will see that we have. I will tell you later on. Okay, basically 3 hours, if possible, up to 5 hours. Okay, and 2 off-class hours for each in-class hour, basically. Okay, now I will purposely make this course hard enough so that you can develop this habit. Okay. Why you want to make this course hard times? Because this is what you need for your other class. Okay, so I basically make you practice that habit right now. Okay, make it a habit. Oh, I see. I think I already made it here, so I don't need this. Okay. Now, big warning that this course runs really fast. Even in regular semester, 15 weeks, this course really runs fast already. So imagine running for 15 weeks, being changed into sprinting for 6 weeks. Okay, make sure you have enough time to study, do your homework, and I suggest you to know each other so that you can study in group. When it comes to your take-home quiz, well, it will be take-home, which I give you at least 24 hours. I would like you to actually work together with other students. You need to write your own. Solution. Okay. Yeah, you need to write your own solution for your quiz, but I don't want you to collaborate. The only time I don't want you to collaborate is when you take the tests, test 1, test 2, test 3, test 4, and the final. Okay, those are the only tests and final that I don't want you to collaborate. But for your homework, I encourage you to collaborate. Okay, work together. Okay, and of course, if you're the one studying and you have somebody asking you for solutions, I discourage you from just sharing your work right away unless that person can share his work. So let's say I know I know the answer question number 1, I miss number 2, that person happens to know question number 2, but not number 1, then yeah, you kind of like barter it, right? Okay, you can do that kind of sharing. But now, if you know this person is not studying, just try to take advantage from you. Say no, okay? Say no, because it's not right for you to earn it and not that person earning it, okay? No, okay? We learn, and that's the reason we are here. That's the reason we are here. That's for the syllabus. Now my website. Let me show you my website. Now, to go to my website, you go to harjuno.com. This is my website. Click on my face or on my name. Okay. Now, the one that is important is this. Go to teaching, previous teaching. This is the list of classes I have taught so far since fall 2007. I put them together. So on the top, you will see at West LA College. I'm a full-time instructor at West LA College, been teaching there since fall 2007. And if you scroll down further, I also taught at East LA College and of course, Santa Monica, right? Now, for Santa Monica College, you can see my pre-calculus classes. Okay, let's say, I think we have fall 19. Yeah, fall 19, you will see my test 1, test 2, test 3, test 4. I don't post the solution here, but let's see your test 1. Your test 1 will look very similar to this. In fact, just assume that you will have the same test. I changed the numbers for sure, of course, right? I changed the numbers. I may change the equation a bit here and there, but the underlying concept for your test 1 will be just like this. Okay, so I need you to actually make sure that you study from this, my old test. I don't even call that sample test anymore because that's my previous test. Okay, as you can see, I have a test from fall 19. I don't think I have any test from spring 20. I don't post it. Oh, maybe I do. Let's see. Yeah, I do for spring 20 Math 2 SMC test 1 and the solution also there. Okay, yeah, test 2 has no solution. The test 1 you can see. Yeah, okay. What else? You can go back to spring 17. And spring 17, I gave test 1 there. This is my test 1. The format may be different, but the underlying concept that I asked are basically the same. Okay, if you compare my test from fall 19 to this spring 17, you will see they are actually very similar questions. Okay, so because my test 1 actually review your foundation in algebra 2 or intermediate algebra. Now, if you think you want to review a bit from intermediate algebra, take a look on my fall 15, for example, or summer 17, my intermediate algebra classes. Then you can see my old test there. I clicked the wrong one earlier here. Let's say fall 15. See, I have intermediate algebra. You can see my test 1, 2, test 3, test 4, right? Okay. Oh, by the way, Math 26 at SMC is college algebra, basically. And the material for college algebra is basically, you can say, the first 1/3 of our Precalculus class. So you can study from their test 1, 2, 3, 4 also. Okay. In our case, test 1. Yeah, in our case, you can study from their test 1 and part of test 2. Besides, at Santa Monica, you can also see the same material from my pre-calculus classes at West LA College. For example, fall 19, spring 19, right? Spring 19, I gave 6 tests there. I gave 6 tests there, not like us, we have only 4 tests. I give them 6 tests because they have only 1 hour meeting every day. So I cannot give them only 4 tests, right? Our 4 tests usually 2 hours, 2.5 hours, right? But because the class only run for 1 hour, I can give them only 1 hour tests every day. Okay, now with this said then, I hope you realize that I don't give you sample tests anymore. You have my actual previous test to study from. Okay, that's one. Video, lecture video. There are some videos that you can study from. If you want to review your intermediate algebra, you can watch from here under East LA College or under Santa Monica College. I wonder if this is still working. Is this what you see? By the way, let me make sure. Yeah, this is what you see. So yeah, you can watch lecture video there. And they have closed caption here, either in Spanish or English. Okay, so if you happen to have a hard time in understanding conversational English, like I did, you know, first time I came to America, I have hard time to understand conversational English. So once I read it in writing, I can understand it better. Okay. And feel free to share this with your relatives, your friends, because it turns out that these lecture videos that I put here are very, very useful for plenty of students. Okay, most students who attend, who comes to my website, are actually not my students. I have like around 6,000 students coming to my website on regular basis during spring or fall semesters. And of course, I have only around 1,000 students at most, 500, I'm sorry, 500 students at most. And the fact that there are 600 people coming to my website means most of them not my own student. Okay, so I want you to benefit from this also. You may be able to have benefit from some lecture videos. I don't know if this link still working, but they usually have some lecture videos here. Let's say Precalculus. I don't know. You play around with this. Okay, you play around with this. Now, one way to actually study, especially when this is online, right? Suppose, for example, today I do. One of the things I will do is graphing, finding equation of a line. Okay, so one thing you can do is, if you think my lecture is not enough, one thing you can do, you go to my lecture the lecture videos page that I showed you earlier. Okay, or you go to YouTube. You go to YouTube and then you Google finding equation of a line. Finding equation of a line. Okay. Yeah, there are a lot of videos online that you can watch and study from. So you don't need to depend on me only. Of course, in my class, I will explain those, but because finding equation of a line is something you should have learned even from Algebra 1, then I do want you to know that already. Okay, I want you to know that already. But suppose I'm saying that suppose you don't get it from my brief review, then try to find it out yourself. Okay. What else I need to say? That's my website, lecture videos. I think that's all. Okay, the important one is my old test that you should be able to have access to and study from. So as you can see, we have tests on the 8th, right? So during this weekend, I expect you to study most of them already, so from my old test. I think I will be able to finish the material for the first test. I hope I will be able to finish the material for first test on July the 6th. So you have 1 day to study. Oh, July the 7th, we still have class. But hopefully we don't have too much material from that July the 7th that goes into your test. Okay, I hope July the 6th, we are done with the material for your test 1. Okay, now that's for the syllabus, the website. I think that's all for now. Let's go to lecture. Let's go to lecture today. In the first part, I think for the next 1 hour, maybe 1.5 hours, I will go over some basic material that I do expect you to know already. So I basically go over this as a review. Basic material that we go over today. The first one will be given 2 points. Find the midpoint. Second, given 2 points, find the distance. And then given 2 points, find the slope and equation of the line passing. And finally, we will talk about equation of a circle. Okay, now then, I think if we have extra time for today, I will go over this one, algebraic expression. Basically, in our textbook, there will be 1.2 and okay. Right now it's 11:53. Let me take a little break. I come back at 12 o'clock. Okay, given 2 points, find the midpoint of these 2 points. So part 1, midpoint. Okay. Let's see the idea first. Suppose I have a number line. Suppose I have a number line and we have 2 numbers on there. Let's say we have 3 and then we have 11. Then what is the point? What is the number right in the middle? You will see this midpoint here is the average of these 3 and 11. Okay, basically I do 3 plus 11 over 2 give me 14 over 2, which is 7. Okay, now you see that this 7 is the same distance from 3s to 11. Okay, 3 to 7 is 4 units. 7 to 11 also 4 units, right? So we call that the midpoint. Now, that's the midpoint formula for 1 dimension. What if we have 2 dimension? What if we have, what if we have 2 dimension? suppose I have a coordinate here. Let's call this 3, 2, and another coordinate here. Let's call this 7, 4. Okay. So what's the point that is exactly in the middle of these two coordinates? What is the point that is exactly in the middle of these two coordinates? Now, this midpoint here, the point in the middle, this midpoint in the middle will be given by the midpoint of the x components, the midpoints of the x components, and the midpoint of the y components. So the x component here is 3, the x component here is 7. So the midpoint will be, you use this formula, right? 3 plus 7 divided by 2, 10 divided by 2 is 5. So the x component of this midpoint will be 5. And for the y component, that was 2 here, and that's 4 here. So the midpoint, the y component of the midpoint will be, the y component for the midpoint will be 2 plus 4 divided by 2, which is 3. Okay, so the y component of the midpoint is 3. Now, so far I used numbers. How about the formulas? Now, the midpoint formula is given as the following. Midpoint of coordinates x1, y1, and x2, y2 is given by the midpoint. I will use capital M equals to a coordinate. It is a coordinate. The midpoint of two coordinates is a coordinate. And the formula is the coordinate of x1 plus x2 over 2. That's how we get this 5 here. That's how we get this 5 here, right? Okay. That's how we get this 5 here. x1 plus x2, the sum of x1, x2 divided by 2. That's how we get that 5, right? And the y component will be y1 plus y2 over 2. That's how we get this y1 plus y2 divided by 2. Okay, now that's the midpoint formula. So if we go over this example again without graphing it, so let's say we have example, find the midpoint of let's call that coordinate P, 3, 2, and coordinate Q, 7, 4. Then the solution, the midpoint is given by the x components 3 plus 7 over 2, the y component 2 plus 4 over 2. That is 5, 3. That's the midpoint. Okay, now of course this question is so simple that I don't think I will ever ask this kind of question explicitly. However, imagine if I reverse the question to be as the following. The midpoint of coordinate P, let's say -4,9, and Q is let's say 5, -1. So imagine if I have 2 points, okay, and this point here is -4,9. That's coordinate P. This is coordinate Q that we don't know. Let's call that X, Y. And this is the midpoint here, 5, -1. Find Q. Find coordinate Q. So let's start. Let's say let Q be X, Y. Now the midpoint formula is given by X, or maybe I call this X1, X2, Y2, huh? So X1 plus X2 over 2, Y1 plus Y2 over 2. Now my midpoint is 5, -1, right? This is my midpoint. Okay, now my X1 is -4, my X2 is unknown. My Y1 is 9, my Y2 is unknown. That's the ones we are looking for. Okay, now then from there we see 5 is equal to -4 plus X2 over 2, and -1 equals to 9 plus Y2 over 2. Now when we solve it, we will get, I will multiply by 2 both sides. I get 10 equals to -4 plus X2. -2 equals to 9 plus Y2. Therefore, furthermore, X equals to 14, Y equals to -11. Now we are not done yet though. We are not done yet. Why? Because we are looking for the coordinate Q, not just two numbers, but the coordinate. Okay, so we summarize. So coordinate Q is 14, -11. Okay, that's for midpoint formula. And what if we have one point and the midpoint, find the other point, find the point on the other end. So the one given here is the midpoint, okay, and the point on one end, you need to find this guy here. Okay, that's the one we need to look for. Now that's about midpoint formula. Second, finding distance. Distance formula. The distance in one-dimensional number line is very simple, of course. Suppose I have 3 here and 11 here, then what's the distance? The distance is 11 minus 3. Okay? Or if you want to take advantage of absolute value, you can say the distance between two points on a one-dimensional line is absolute of x1 minus x2. Okay, so we can say this way. In case we don't know which number is larger, so we use absolute value. Is it okay? We use absolute value in case we don't know which one is larger. Now, but our focus will be the distance formula in 2 dimensions. Suppose I have 2 points on a coordinate system. Let's call that coordinate P, x1, y1, and coordinate Q, x2, y2. Now we are interested in finding the distance from one point to another point. Now the way we will do this is by using Pythagorean theorem. Okay, so I will find the horizontal distance. Okay, so which is, this is x1, this is x2, and the vertical distance, this is y2, this is y1. Okay, so the distance here is x2 minus x1, if we know x2 is greater, okay? And in this case here, the distance is y2 minus y1, if we know the distance is greater. Now, the thing is Pythagorean theorem, let's call this D here, the direct distance. Okay, the direct distance between coordinate P and then coordinate Q is given by the Pythagorean theorem. We apply Pythagorean theorem, which is the square root of x2 minus x1 being squared plus y2 minus y1 being squared. Okay, that's distance formula. Yeah, this notation means the distance from point P to point Q. Okay. Of course, you can ignore the PQ notation there. You can just write it as distance squared equals to x1 minus x2 minus x1 squared plus y2 minus y1 squared. And then after that, you do the square root. Okay. Now, Thomas, what happened if x2 is smaller? Let's say the x2 on the number line is smaller than x1. Well, we don't worry about it because whatever the value we have here, either positive or negative, once we square it, it will be the same number. If negative, let's say negative 4, you square it, it becomes positive 16. Positive 4, when you square it, that's still positive 16. Okay, so we don't really worry about the order of subtraction as long as we know we will square it later on. Okay, let's say we get an example. Let's get the example we have up here. Let's say we get this one, example 2 there. Let me answer it. No, I'm sorry, not this, not this. It's this one. For example, find the distance between P and Q. Then the solution. Let's deal with distance square first. D square is x2 minus x1 squared plus y2 minus y1 squared. This is 4 squared plus 2 squared. That's 16 plus 4, which is 20. So the distance is square root of 20. Now then, if you can simplify this, keep the exact value though, not approximate. So don't use calculator too early. Okay, don't use calculator too early. If you can simplify this, you see that this 20 is actually 4 times 5, right? And 4 is a square number. So square root of 4 is 2, square root of 5. Now after this, if you want to use calculator, go ahead. Okay, if you want to use calculator, go ahead. Now before I go on, well, you can just use your calculator. Yeah, when you use calculator, in my class, let me use red color. In my class, get the exact value then, so this one is required, get the exact value first. Then the approximate value if necessary, if needed. And round it to 5 decimal places. Okay, 5 decimal places. Now, here's the thing. In my test or in my quiz, if you answer 2 square root of 5, I take that answer and you get a full point, together with the work, of course. So in other words, you don't need to give me the decimal because you give me the exact value. Okay, now I want you to give me the exact value first before you get the decimal, even if you want to get the decimal. Okay, there are some cases you will see later on, it's quite impossible for us to get the exact value. Okay, so we need to use calculator to get the approximate, but that's much later. At this basic level here, I do expect it to be able to get the exact value. Okay, that's for distance formula. That's for distance formula. Let's do one more problem. Let's do one more problem. Let's do one more problem. Suppose, for example, find the distance between, you know what, let me change the problem, sorry. The distance between five, 3 and x2, y2 is, let's say, 4. And x2, y2 is on the x-axis. Now, what we know about every coordinate that is on the x-axis? If it is on the x-axis, let's see. Any point on the x-axis, must have something, 0. Is that right? Must be something, 0. So let's say we have 5, 3 somewhere, 5, 3, let's say here. Okay, and then the distance from that 5, 3 to this x2, y2, the distance is 4. Now then, what will this be? Now, once we know this on the x-axis, then we can update this right away that it is on the x-axis, right? So it must be x2, 0. Is it right? Must be x2, 0. Let me use red color instead. Because I use red color there. Now then, you see the distance between this 5, 3 and x2, 0 should be 4. So d squared equals to x2 minus x1 squared plus y2 minus y1 squared. The distance is known to be 4. x2 is unknown. x1 is 5. y2 is 0. It's because it's on the x-axis. y1 is 3. So I get 16 equals to x minus 2, x2 minus 5 squared plus negative 3 squared, that's 9. So 7 equals to x2 minus 5 being squared. Then how do we solve this? I apply square root property, x2 minus 5 equals to plus minus square root of 7. Therefore, x2 will be 5 plus minus square root of 7. So there are actually two coordinates that satisfy this situation. One of them here and the other one here. Okay, the other one here. If I extend this. Okay, there are two of them. Now, what are those coordinates? I have to write it in coordinates. So, though the coordinates are there are two solutions, right? 5 plus radical 7, 0, or 5 minus radical 7, 0. Okay, so using distance formula, we can find two coordinates on the x-axis that has distance 4 units from 5, 3. Actually, let me transition to equation of a circle. Equation of a circle. So this is actually point number 4, as I remember. Equation of a circle. Suppose we have this situation. Let h, k be the center. Let me call that coordinate C, which is the center of a circle with radius r. Then the equation of the circle is given by x minus h squared plus y minus k squared equals to r squared. Let's see, how do we get that? So suppose I have a circle. Let's say I have a circle, and the center of that circle is coordinate C, which is h comma k. We said earlier that the radius is r, right? Now, then what is the equation of that circle? Let's assign some variable first. Let this coordinate here, coordinate xy, be any random point on the circle. Any point you choose on the circle. Okay, so proof. Let x comma y be a coordinate on that circle. Now we know that the distance from this coordinate to the center must be equal to the radius, right? Okay, so what we have is the distance will be equal to the square root of x minus h squared plus y minus k squared, where the d now becomes the radius. Notice that if I square both sides from here, I get what I need. That is r squared equals to x minus h squared plus y minus k squared. Okay, now let's do a little example. What example is this? Under this topic, example 1 under this topic. Find the equation of a circle centered at, let's say, -4,3 with radius 6. Solution. It must be x plus 4 squared. Remember, because this is our h, right? This is our h, this is our k. Okay, and the formula is x minus h. Now, because my h is negative, then x minus h becomes x plus 4. Okay. So continue from, in this question, I'll get x plus 4 squared plus y minus 3 squared equals to 6 squared. Or we can write it as x plus 4 squared equals to y minus 3 squared equals to 36. That's for example 1. Example 2. How about this then? Part A. Describe or find, maybe. Just go ahead. The following are equation of a circle. Find the center and radius. Find the center and radius of x squared plus y squared equals to 5. And you see the center is, this is x minus 0 being squared, right? And y minus 0 being squared. And the radius is, this is the position for r squared. So this is square root of 5. Okay, you can see this as x minus 0 squared plus y minus 0 squared equals to square root of 5 being squared. That's how we get the center to be the origin, and the radius is radical 5. How about find the radius, the center and radius? X minus 3 squared plus y plus 7 squared equals to, let's say, 28. The center is h minus x minus h, so the h is 3, plus y minus negative 7. So the k is negative 7. That's the center. The radius is square root of 28, which is 2 square root of 7. Now, the format of the equation of the circle I show you here is also called the standard form. That's the standard form. Standard equation of the circle. Now, there's something called general equation. Let me go over this equation here. This is standard equation, right? This is standard equation. Now, how about general equation? General equation has one side of this equation becomes 0 and normal squares. So what I will do is I will FOIL this. I will FOIL this and FOIL this. Okay, and then I will move this 28 to the left-hand side. Then later on we will get the standard, the general form. Now, if I FOIL x minus 3 squared, that will be x squared minus 6x plus 9. Yeah, try to imagine this. X minus 3 squared, that's x minus 3 times x minus 3, right? Okay. If you remember, that's a perfect square, right? Okay, so if you happen to memorize the pattern, go ahead. But then you actually FOIL that. So the first times the first give me x squared. The first times the second give me negative 3x. The second times the first give me another negative 3x. Then the last times the last give me plus 9. That's how I get that x squared minus 6x plus 9. You can also memorize the following pattern. A minus B squared is A squared minus 2AB plus B squared. That's another useful formula from beginning algebra, intermediate algebra, worth memorizing. Okay, so this is the expansion from the yellow one plus, let me ask you to expand the blue portion. That will be y squared plus 14y plus 49 equals to 28. Then I will set one side equals to 0. And I will get x squared plus y squared. So I reorder them, x squared plus y squared being written first, because they are actually higher exponents, so we write them first. And then the degree of 1, x and y, right? We follow alphabetical order. And then the constant, plus 9 plus 49 minus 28 equals to 0. Then I will combine this here, make it into a constant, x squared plus y squared times 6x plus 14y plus, what's that, 21 plus 30 equals to 0. Now, this is what we call general equation of the circle. Okay, general equation of a circle. Now, the thing is, I need you to also know how to go backward. Suppose I give you the general equation of a circle. Find the center and radius of, let's say, x squared plus y squared minus 8x plus 10y equals to 0. Now, this is in general equation. This is the general equation of that circle. For me to find the center and radius, one thing I can do right now is to convert that first to standard form. This is the general. Convert general equation to standard equation. Then we read or get, to be more precise, the center and radius. Now, to do so, I will need to basically pretty much reverse what I did up here. I need to reverse what I did up here. I need to reverse it. Okay, starting from the general equation, go back to standard equation. What do? I will need to rewrite them first. So I rewrite the x terms with x terms, plus the y terms with the y terms. Now then, in the next step, we will complete the square. how do I complete the square for x squared minus 8x? The secret is this. As long as the leading coefficient is 1, then you get the coefficient of x divided by 2 and then whatever the quotient squared. Okay, now let's complete the square procedure. The leading coefficient needs to be 1 before we start this. And once the leading coefficient is 1, divide the coefficient of the x, which is we usually call b, divided by 2, whatever the quotient you square. Okay, so I will add 16 here. Okay, now then how about the y's? Y squared plus 10y, the leading coefficient already 1. So the coefficient of the y in this case is 10 divided by 2. And then you square it. Okay. The coefficient of y, remember the leading coefficient has to be 1 first. This has to be 1. Otherwise our procedure will not work. Okay, the leading coefficient has to be 1. Now, then once the leading coefficient is 1, then take the coefficient of x in this case, coefficient of y in this case, divided by 2, whatever the quotient, you square it. Now, that's the number we add to both sides here. Now, the procedure guarantees that on the left-hand side, we have a perfect square, x minus 4 squared. And this negative 4 actually coming from here, whatever you divide, whatever the quotient when you divide by 2. Okay. Plus y plus 5 squared. How do I get that plus 5? From here. Okay, and then equals to 41. So the center is 4, negative 5, while the radius is square root of 41. Okay, so I hope you realize that from example 1, if we know the center and the radius, we can get the standard equation, right? From standard equation, which is the most common equation we want to get for a circle. If you want to convert it into a general equation, you can. But you also need to know that if you have a standard equation, can you tell what's the center and radius directly by just looking at that? Okay. Now, in the last example we did, down here, basically, if I give you a general equation, can you massage that, rewrite it to be in standard form? Then, from there, you get the center and the radius. Okay, so given the coordinate and radius, get the equation. Coordinate and radius, you get the equation. From the equation, you get the coordinate and radius. You need to be able to do both. Okay, now that's for equation of a circle. I happen to skip part 3. Part 3 is given 2 points, find the slope and equation of a line. passing those points. For part 3, given 2 points, find the slope and equation of the line containing those points. Now let's review a little bit. What is the slope? Suppose I have a line containing 2 points. Let's call this coordinate P, x1, y1, and call this coordinate Q, x2, y2. Now the slope of a line is defined to be, the ratio of rise over run of any 2 points on the line. So the slope M is defined to be the ratio of rise over run. Now in this case, the rise will be y2 minus y1, and the run will be x2 minus x1. Okay, so the equation for the slope of a line given 2 coordinates contained in that line is y2 minus y1 over x2 minus x1. Okay, so for example, let's do the slope first. Find the slope of a line containing these 2 coordinates here. Now the slope of a line is denoted by lowercase m. So every time you give me the slope, write it with m equals. Okay, write it with m equals. So the slope of this line here will be y2 minus y1 over x2 minus x1. That will be 2 over 3. Now you may wonder, Thomas, how do I know which is the first coordinate, which is the second coordinate? Actually, either one. As long as you are being consistent, if you call this the first one, then this will be x1, y1. And if you call this your second coordinate, then you call this x2, y2, or vice versa. Okay, what you don't want to do is you call this your x1, but this is your y1. No, don't do that. Okay. Well, you can try. Like suppose I happen to choose incorrect order, not incorrect, the different order, not incorrect, different order. But as long as I maintain which is my first, which is my second. Okay, so let's say I use, this is my second coordinate, and this is my first coordinate instead. Okay, so that will be y2 minus y1 over x2 minus x1. I'm sorry, I made a big mistake. It should be 4 here. It should be 4 here. So it becomes 1/2. So here, if I compute, I get -2 over -4. You see the negative cancels, right? So it becomes 1/2. So either way, as long as you maintain the order, either this one, y2 minus y1, or you can also do, let me use different color, lighter maybe, equals to y1 minus y2 over x1 minus x2. It's also fine. This is also okay. Now then, suppose I follow up with this question. Continue. Find the equation of the line. Containing those two coordinates. Now we get earlier, we get the slope is 1/2, right? Now then from here, how to find the equation? There are two methods. Method one, we use point slope form. In which we have y minus y1 equals to n times x minus x1. So y minus 2 equals to 1/2 times x minus 3. If I use coordinate 3, 2. Okay, so the slope is 1/2. And the coordinate is 3, 2. Okay, but this should not be, point slope form should not be the final answer. Point slope form should not be the final answer. You need to change it into slope intercept form or what we call standard form. So y equals to 1/2 x minus 3/2 plus 4/2. Y equals to 1/2 x plus 1/2. This is what we call slope intercept form. Slope intercept form has the pattern y equals to mx plus b. Now method 2, even though it seems to be more straightforward, I prefer method 2, by the way, slope intercept form. It has two steps. One very small steps, we know y equals to mx plus b. Okay, we know the slope is 1/2, right? So we get y equals to 1/2 x plus b. Now then I need to find the b. To find the b, I can use either one of the coordinates. You can use the first coordinate 3, 2, or you can use the other coordinate. What's the other coordinate? 7, 4. Let me use 7, 4 this time. But if you use 3, 2, you will get the same thing. Okay, so my y is 4, my x is 7, okay, plus b, and I will solve for b. That's 8 over 2 equals to 7/2 plus b. Therefore, my b is 1/2. But I'm not done yet though. The equation of the line, so the equation of the line is y equals to 1/2 x plus the b is 1/2. You see that I can use either one of the coordinates and still get the same slope intercept form. Okay. Now remember, point slope form is not an acceptable final answer. Point slope form is not an acceptable final answer. Slope intercept form, y equals to mx plus b, is the most common acceptable final answer. Or another one is called general form. Sometimes they call it standard form. Standard or general form of a line is given by ax plus by equals to c, where a, b, c are not in fraction, and a is non-negative. So suppose I need to rewrite that equation here into general form. Let me multiply both sides by the LCD 2 first. So I will multiply by 2 both sides. I get 2y, oops. I get 2y equals to x plus 1. If I move the x to the left-hand side, I get negative x plus 2y equals to 1. But I need the x to have positive coefficient. It's all integers already right now. Okay, it's all the integers already. Okay, but I need to make this part here to be positive, and to do so, I'll multiply both sides by negative 1. Then I will get x minus 2y equals to negative 1. Okay, now this is what we call the standard or general form. Basically, when we say general form, the x and y on the same side of equation. Okay, x and y are on the same side of equation. And we don't have fractions. What happens if we have fractions? They multiply by the LCD. Okay, now the last part here, that the leading coefficient for x, the coefficient for x, which is a, has to be non-negative, is actually a quite common requirement, even though it's not enforced 100%. Okay, in my class, as long as you don't make it negative, as long as you don't make it fraction, as long as none of these a, b, c are fraction, then you are fine. So you can leave your answer. You can leave your answer like this, even though I don't like it. I cannot mark you wrong. Of course, this is the preferable one if I ask you to write it in general form. Okay, in big story, either you write your answer in slope intercept form or in general form. Okay, you should not stop at, you cannot stop at point slope form. No, this is no. Okay. Now, right now is 1 p.m. Let me give myself a little break. I'll be back at 1:10. Okay, let's continue. I'm done with these sections here. Let's see if there's any suggested homework I can give you. Suggested homework you don't need to turn in. Again, suggested homework is something you don't need to turn in. Only the homework which I call quiz that you need to turn in. Okay, let me find out where do they put this part here. Oh, okay. Suggested homework. Again, suggested homework means you don't need to turn it in. suggested homework from 2.2. I don't expect you to have your textbook today, but I guess tomorrow, I guess Wednesday, I should expect you to have the book already. Okay. Meanwhile, I will try to find a way to get some exercise set. For example, later on, the pictures for these suggested homeworks, I will post it on our discussion board. So here's what happened. Here's what happened. I will, like the lecture notes, I will post it on our discussion board for the day. And for suggested homework, I will also post it there, the pictures for today and tomorrow. Okay, so from 2.2, your suggested homework will be is number 37 to number 57, odd ones. And let me see more. They should have equation of lines somewhere. Yeah, you can also do from 2.1 number 9 to number 13. Number 23 to number 31. Again, just do the odd ones. Okay, that's the suggested homework from, I mean, hold on. I have not done with 2.1 and 2.2. No, I'm not done with those yet. Okay, I just think that these are the material that quite easy for us to go over in the first day of class without textbook. Okay, such that I go over them and give you the suggested homework. But I still need you to get the book, and I think in a couple of days, maybe on Wednesday or Thursday, then we will go back to 2.1, finish up the rest of the material from those two sections. Okay, let me go back to let me go back to 1.2. So 1.1, I think is way too easy, so I don't even go over them anymore. 1.2 is on exponents and radicals. I don't think I can finish these sections today, though. But let's see what are the formulas that we need to remember as a review for exponents. The first one, we usually call that product rule. X to the A times X to the B equals to X to the A plus B. Okay, for example, x cubed times x to the 7, that's equals to x to the 10. Now, our textbook may, in Algebra 1, you may see that we applied it to integer exponent, but it actually applies to even rational exponent. Let's say if I have x to the 2/3 times x to the 3/4. Now, what will that be? Then I need to do it aside. 2/3 plus 3/4. The LCD is 12. This is 8. This is 9. So that's 17/12. So later on, this will be x to the 17 over 12. Okay, what I'm trying to say is the rules that we apply for integer exponents still apply even if the exponent were a rational number or even irrational number. Okay. Second, something called power rule. X to the a to the b equals to x to the a times b. For example, x cubed to the 7 equals to x to the 21. Now, if you wonder why the formula looks like this, let's go back. For example, this x cubed here, we can write it as x times x times x, right? Times x to the 7, we can write it as x times x times x times x times x times x times x. There are 7 of them, right? Now, then in total, you will have x to the 10, right? So when you multiply the same base, in this case, common base x, then you add the exponents. Okay, now what happens if when we have x cubed to the 7? Now x cubed to the 7 means x cubed times x cubed times x cubed 7 times. Now instead of adding adding the 3 7 times, instead of adding the 3 7 times, I will multiply 7 by 3. That's how I get that x to the 21. Now the thing is, this rule again still apply to rational exponent. Let's say x to the 2/3 to the power of 3/4. So when I multiply 2/3 by 3/4, cross cancel here, cross cancel here, I get 1/2. So this is equals to x to the 1/2. Okay, that's for product rule, and then power rule. More. We have this rule here, x times y to the power of a equals to x to the a, y to the a. So for example, 3x quantity squared that is equal to 9, which comes from 3 squared times squared. Okay. And suppose we have, let's say, x squared y cubed to the power of 1/2, let's say. Then this is x squared to the power of 1/2, y cubed to the power of 1/2. This is x, y to the 3/2. Assuming that x and y are all positive, or 0. Now, the consequence of rule number 3 is actually rule number 4, in which instead of having product inside the grouping symbol, if we have quotient. So x over y to the a is x to the a over y to the a. By the way, this is the principle we use to get the exponent of fraction. Let's say if I have 3 over 4 to the power of 3. Then the top one will be 3 cubed, which is 27, and the bottom one is 4 cubed, which is 64. Of course, we can apply them also to variables, right? Okay, we can apply them also to variables. And it also applies when we have rational exponents. So you see my column here, my columning, when I do the column, the one on the left-hand side of this red line here is the theory, the rules, okay? And then the middle column is the application into integer exponent. And the example on the far right here is the examples when we apply that to rational exponents. Okay. Now, furthermore, the cancellation. Suppose we have common base a to the x over a to the y. This is a to the x minus 1. Okay, suppose let's say x to the 7 over x cubed. That will be x to the 4. Okay, now, oh, by the way, we don't really like to have negative exponent. We don't want to have negative exponent in our final answer. So if we have, for example, x to the 4th over x to the 10, instead of making it x to the negative 6, we make 1 over x to the 6. Okay, imagine if you have 4 x's on the top and 10 x's at the bottom. Four of them cancels. But if 4 of them cancels, you will have, we cancel by dividing, right? So when we cancel 4 of the x, then we get 1, not 0 on the top. Okay, and then at the bottom we will get x to the 6. Okay, that's how we get this answer here. Now, the last example that I did, actually explains what it means to be negative exponent. X to the negative 1 means 1 over x. X to the negative 1 means the reciprocal of x. Okay, so let's say 3 to the negative 1, that simply means 1 over 3. Now, however, be careful with this. 3x to the negative 1 means 3 over x, because the negative 1 exponent only applies to x, not to 3. Okay, maybe I write it this way then. So the exponents only apply to x. The 3 has no exponent included. Now, contrast that with 3x to the power of negative 1. Now, 3x in parentheses to the power of negative 1 means the reciprocal of 3x. This is 1 over 3x. Okay. Of course, you can also see it this way. 3x in quantity, power of negative 1. You can see that as 3 to the negative 1, x to the negative 1, which means 1 over 3 times 1 over x, that's 1 over 3x, right? You can also see it that way. But make sure that you distinguish, make sure you see that these two expressions are not the same. Okay, those two expressions are not the same. Okay, now that also implies that x to the negative n is equal to 1 over x to the n. Okay. Let's do some examples from the book with all these rules before I go further into radicals or negative exponents. I did some negative exponents already, but I will do more. I do more. Give me a second. Give me a second. Let's say, for example, first example, suppose I want to simplify. Let's say negative 5x cubed y to the 5th times 4x to the 7 y to the 9. Then I will compute this negative 5. It's multiplication, right? So negative 5 times 4 will give us negative 20, right? And then y cubed times y to the 7 will be, I'm sorry, x cubed plus x to the 7 will give us x to the 10. And then y to the 5th times y to the 9 will give us y to the 14. Okay, that's the first one. What if we have this? Suppose I change the question a bit. Negative 5x cubed y to the 5th squared times 4x to the 7th y to the 9th cubed. Then you will see I will tackle this one by one. I will do the exponent first here and the exponent here. I cannot multiply them first though, because in order operations, exponent comes first. Okay. In order operations, exponents come first. And then after that, I will do multiplication. Okay, so the first part, let me change the color for the second. Let me use green here. So the red part will be negative 5 squared, that's 25. X cubed squared is x to the 6th. Y to the 5th squared is y to the 10th. Now I hope you can see that. Now then, let me go on with the second part, the green part. 4 cubed is 64. X to the 7th cube is x to the 21. Y to the 9th cube is y to the 27. Now then, I put things together. The coefficient times coefficient give me 25 times 64 should be 1600. And then the x to the 6 times x to the 20. 1 is x to the 27. Right? And then for the y part, that will be y to the 37. I don't think I need to color it anymore. Huh? Yeah, I color it so that you see how I get those numbers. But in your real test or your quiz, of course, you don't need to color it this way. You don't even need to underline it. Okay, but I still need to show you. I still need you to show me the steps though. Okay, now the third one's part 3, example 3. Let's say I have 3x cubed over, maybe make it 5 instead of 3. 5x cubed over y squared being cubed times y cubed over r squared being squared. Again, I need to do the exponents first. Let's call this the red part. And then this is the green part. So later on, I will have the product of the red and then green. I have the product of red and then the, with the green. Now my red part will be 5 cubed is 125, x cubed being cubed is x to the 9 over y squared cubed is y to the 6. Now, if you think my lecture is a bit too fast, when you rewatch the recording, okay, you can slow it down. You know, you can pause it, right? Okay. And then for the green part, you will get y to the 6 over, I'm sorry, let me change this to x here, and x to the 4. Then, if I can cross cancel, I cross cancel, right? As you can see, y to the 6 and y to the 6 cancel both, okay? While x to the 9 and x to the 4 cancel, I get x to the 5th extra on the top. Supposed to be this, okay? But because I divide by 1, then it will be just 125 x to the 5th, and that's it. Okay, another example. U to the negative 4 and phi to the third to the power of negative 3. Now there are more than one ways to do this. Okay, let me show you. The first way is a very textbook way. Very textbook way. Basically, I distribute the exponents. U to the 12th, phi to the negative 9, but we don't like negative exponents, so I bring it down. Okay, that's the first method. The second method, more into following order operations. So what I will do is I rewrite the negative exponent inside first. So I get phi cubed over u to the 4th to the power of negative 3. You see that? This guy here, I bring it down. Okay? So at least inside the grouping symbol in the parentheses, I don't have, inside the parentheses, I don't have negative exponent anymore. Now, then the next challenge is how do I get rid of this negative exponent? It means reciprocal, right? Negative exponent means reciprocal. So what I do is I do the reciprocal u to the 4th over phi cubed, but this time instead of the power of negative 3, it becomes to the power of 3. Do you see the change? No more negative. Okay, reciprocal. You see this switch here? Okay. And then, last step, I distribute that exponent 3, so I get u to the 12th over phi to the 9. See, I get the same answer. Right? Now, part B may be longer, okay, but it's up to you which method you want to do. Okay, just show me work, show me the legitimate, acceptable work. Okay, either part A, this method here is okay, I'm cool with this, I'm also cool with this. If you ask me which method I personally prefer, I prefer the second one. I just don't like negative people. You know, even though that sentence is a negative sentence, right? Yeah, yeah, I don't like to deal with negative exponents. Therefore, I try to get rid of that earlier. Okay, but of course, it takes me slightly more steps. Okay, that's for these examples here. Let's do more. Let's do more. Let's do more. Let's say example number 5. If I have, what is it? 27 x to the negative 5 y to the 7th over, what is it? Maybe 72 x to the negative 4 y to the negative 3. Now, what I will do is I will simplify them, maybe just simply rewriting them one by one. First, I will tackle this thing. 27 over 72, do they have common factor? I think they have common factor 9. So if I reduce by 9, I get 3. If I reduce by 9, I get 8. If I can reduce that further, I do it later. But for now, let me just stop there for the coefficients. Now, how about the x's? X to the negative 5 on the top becomes x to the 5th at the bottom. X to the negative 4 at the bottom becomes x to the 4 at the top. So negative exponent on the numerator becomes positive exponent on the denominator. Negative exponent on the denominator becomes positive exponent on the numerator. Okay, now then the y parts, y to the 7 is already positive exponent, so I leave it up there. Y to the negative 3 at the bottom on the denominator, I move it up to make it positive exponent. So you see, this is my x part here, and this is my y part. If I go on, simplify further, I will get 3y to the 10th over 8x. Okay. Now, let me give you the suggested homework. I'm not done yet with this 1.2. I was planning to do more on that 1.2, but with the time I have, I don't have enough time. So let me give you a little suggested homework. Otherwise, it could be too heavy for you tomorrow. Suggested homework 1.2a. When I use this notation 1.2a, it means I don't finish this yet. Okay. Which question is good? I would like you to try question number 11 to number 29. 11 to number 29. Okay, let me stop here for first. I still have like around 20 minutes, but I would like to explain to you some things. Okay. I usually do this. I post the notes of the lecture on my discussion board. So this one here, yeah, this one here. And at the beginning of the material, at the beginning of the day, I usually tell you what I will cover. So this one here, I will save it. I change it into PDF. Let me call that Math tool 0629 basic. I wonder if you see what I do here. Let me share my screen instead. So you see my inner working. Okay, and then for this guy here, I will save it as Math 20629 1.2a. I save them both as PDF, and then I will go to my Canvas. Now, let me do this first. So this is your student view. Now, if you want to get my old recording, the recording from today or other day, whichever days, what you can do is you go to that Confer Now. You go to this Confer Now here. Huh? Why can't I do that? Anyway, I'll show you mine. So if you go to Confer Now, okay, then you go to Event Recordings. Now we are not done with the recording yet, so it won't be up here. Okay, what you can do, then you check for recording. Okay, either you click this one or you click this one. Sometimes you check this one doesn't work, but when you click this one, it works. Okay, but click this one first and then click that one. Okay, I don't know what yours look like though. Okay, but I will post it there. I mean, it's not that because I record it, then it will be automatically saved into the cloud. Now, about the notes, I post the notes for the day here. So on the discussion board for the day, I will post the lecture notes. Lecture notes. Okay, that's the basic. And then 1.2a. So as a student, if I have student view, if you want to see the lecture notes for today, you go to the discussion for that day. You go to the discussion for that day. At the end of the class, I will post it here in case you miss my lecture. Actually, even if you attend my lecture synchronously, you will still be able to benefit from this lecture notes though. Okay, so you compare your lecture notes with my lecture notes. Okay, and one more thing. Remember the videos that we supposed to have? You don't have that now. The videos that you're supposed to have, right? What I usually do is this. What I usually do is I will take the recording. I will take the recording, I download it, and I post it on YouTube. I post it on YouTube. Now, once I finish, the process will take like around 1 or 2 hours though. Okay, so do not expect me to be able to have it done right away. So, I mean, our lecture done at supposed to be at 2 o'clock, right? You can expect the videos to be online. Like the earliest will be 3 hours. The earliest I think will be 3 hours after the end of the class. So let's say 5 o'clock in the afternoon. It depends on how fast Canvas and Zoom can finish processing the recording and put it here. Okay, yeah, I can click this one and you will see there's no recording yet. There's no recording yet. Okay, well, anyway, later on, once I'm done, I will download it. Okay, I will download it and then I post it back into the discussion board. So you will see here, for example, you will see here lecture videos. Now, I connect that with YouTube so that you can watch that video without the need of being going to Canvas. Now, let me show you what I have from last semester. Last spring, for example. This is my spring 2000. This is my spring 2020 last semester. Okay, let's go to one of their discussion. say this one here. So you see, I will have lecture videos and lecture notes. Okay, I have lecture video and lecture notes. Now, how do you get the lecture video directly from YouTube? So far, I don't have any videos yet, but you can see the following. If you go to YouTube, let me make sure that I get to share the same thing. If you go to YouTube, now go to Thomas Harjuno, search my name. Put my name here. And then go to playlist. Then you will see some classes. Please ignore this. My son, 3 years old, still have used my account. Okay. Now then, this is my summer 20 elementary statistics at West LA College. Okay. Now, and this math 2 here is my Precalculus from last semester, from spring 2020. So we moved to online. We moved online last semester, I think toward the end, the middle of March. So at that time, I get to chapter 3 already. So later on for you, starting from chapter 3 and on, you can watch the lecture video ahead before you come to class already. I hope by having using lecture video from last semester and posting it to YouTube, we can actually speed up our learning process, and we can spend more time in class by just doing less lectures because you watch the lecture video online or on YouTube already, right? And we can spend more time in doing examples, exercise, and who knows, problems from my old tests. Okay, yeah, that's how you get to my YouTube channel. You go to YouTube, type my name, Thomas Harjuno. Okay, let me go back to our class. What else do I need to say? I don't want to miss anything on the first day of class. Yeah, so tomorrow, oh, by the way, if you want to go to Zoom, you can just click confer now directly. As I know, you can just click that directly. Okay. However, in case that you don't know what to do, you can go to the discussion of the day. You click the discussion of the day here. Okay. Make sure you go to the right. Make sure you go to the right date though. Okay. Discussion of the day. Today is June the 29th. So you click this one. What I usually do is I give you the link for the confer Zoom, and then the password. Now here I give you 2 passwords. They seems to be the same. They seems to be the same. But to be honest with you, until now, for many months, I still don't know what does this mean. Is this lowercase l or capital I? So if you see this lowercase l or capital I, and you use the password doesn't work, then try the other options. Okay. So if I have a chance, then I will write you both. Again, this seems to be the same, right? But this is lowercase l. This is uppercase I. Because of that possible confusion, then I write them both. Okay, but I don't think you should have any issue if you go to Confer now directly. Okay, that's where I will stop today. I will see you tomorrow. And if you have any question, feel free to send me an email. I will try my best to reply that. I prefer you to send me email to my school email. I prefer you to send me email to my school email, this one here, or my personal email. But I don't mind you to send me email through this Canvas email. Okay, Canvas email is okay. But for me to get this, your message, I need to go to Canvas first to get your email. Okay, so I prefer you to send me email directly to my school email or my personal email, because I will get both of them on my smartphone directly. Okay, I think that's where I will start today. Tomorrow we will start the lesson at 11:10, and I hope I have more students instead of me by myself today. Okay. Make sure I close it right. Okay, that's for today then. See you tomorrow.